Welcome, geometry students. If you do not have your workbook out, you will want to grab it and see if you can find this page that is talking about an investigation of the Pythagorean theorem and distance formula. Okay, it should kind of look like this. At the beginning, you should have a step one right there. I'm going to have you do steps 2 and 3 on your own and then kind of continue and catch you up to speed when we get to step 4. So by the time you are finished with this short discussion, you should see 2 ways to calculate a length in a coordinate plane. Okay, and one of those is to use a triangulation, so creating a triangle and the Pythagorean theorem. And one of those is to use the distance formula, which actually comes from the Pythagorean theorem. So we're going to go ahead and it says, step 1, use the Pythagorean theorem to find the lengths of each segment by drawing the vertical and horizontal lines and creating a right triangle. Okay, and we already talked about how to simplify a radical. It says leave your answer as a simplified radical. So hopefully you already watched the video on how to do that. Okay, so here we go. We're going to go ahead and just use this part D triangle right here, and I'm going to drop that line to that point, and I'm going to make a horizontal line to that point, and we're just going to use our grid to determine the lengths of these sides. This is a right angle right here. And hopefully most of you guys are remembering the Pythagorean theorem, which says in any right triangle, you can take the sides that are the legs, the parts that form your right angle, and square them and use that to find the length of the hypotenuse. So you might remember a squared plus b squared equals c squared. Some people write it because these are called legs right here, and that's a leg, and this is the hypotenuse. Okay, some people say leg squared plus leg squared equals the hypotenuse squared, or the square of the hypotenuse, so you might have heard it like that. So there's a little review the Pythagorean theorem for you, and let's apply it here. So we have 1, 2, 3, 4, 5, 6. I can see 6, a space of 6 from this point to the corner, and it looks like 1, 2, 3, 4, 5, 6, 7, 8, a space of 8 from this point to the corner. So if I want to find my hypotenuse, I can do the following problem. I can say 6 squared plus 8 squared equals c squared, and we get 36 plus 64, which is going to give us 100 if we add those together. And the last step, remember, in calculating that hypotenuse is to take the square root. Well, this is really handy. 100 is a perfect square, so I know my value of c is 10. Okay, it doesn't always work out that great, but a lot of times it does. What I would do at this time is I would pause your video. I know, I'm going to put you to work here. And try one of these 3 problems, A, B, or C, and see how that goes for you. See if you can go ahead and figure out what those distances would be. And I'll be right back with you. All right, so I hope you took a minute to try A, B, and C. I want to give you the correct answers here just in case you were following that directive. You should have gotten the square root of 20 as an answer here. And if you reduce this, remember, I'm just going to model simplifying some fractions here for you guys real quick. 4 times 5 is the same as 20. The square root of 4, that's a perfect square, so it comes out of the radical, and 2 root 5 is your exact answer. For part B, you should have gotten the square root of 40, And you have another perfect square here that you can see. We know 4 times 10 is the same as 40. So 4 is a perfect square. That's going to come out. 2 root 10 is your answer here for part B. And for part C, this one was a little trickier. Root 68. I know that's the same as 2 times 34, and 34 is the same as 2 times 17. So I have that pair that I was talking about in our previous video. So I know one of those pops out. That's the same as 4 if they're together. So when I take the square root, I have 2 root 17. So hopefully that went really good for you guys. Okay, so this idea of making a triangle is awesome, right? You can do it every time. It works every time. But if you do not want to have to graph every time, what you can do is you can take 2 points that are given. This is the point 8, 15. And I'm just going to do a little sketch here. I'm going to go over 8 and up 15. So I know that that's at 15. And I'm going to put a little dot. And I'm going to try and find the distance between this point W at 8:15 and the point negative 7:23. I'm going to be over up here into my other work. Negative 7. And here, I'll just erase this real quick. Give us a little more room. Negative 7 and 23. All right, so I know that's up there at 23. And that is a point M. Okay, so if I draw a line between these 2 points, and I want to know what that line is in terms of its length, I can go through this process of triangulating again, but really what I'm doing is I really need to just I need to figure out the length up and down right here between the y value for M and the y value for W. So I need to figure out that vertical distance. And then I need to figure out this distance all the way across here, this horizontal distance from M to W. So it's like I'm building that right triangle, but I'm going to do this with a formula instead. Okay, so I'm going to go ahead and write these points right here, 8:15, and the point negative 7 and 23. Okay, and what we can do is we can actually subtract these values. And it really doesn't matter which one I put on top. I put the point 8:15 first, the point negative 7:23 next. But I want to subtract my x values and I want to subtract my y values. Let's see if that looks like it's going to work out. 8 minus a negative 7. So I'm actually subtracting a negative, which means I'm going to get 15 as the total length between these 2 points for my x difference. And that looks about right. From negative 7 to 8, that looks like 15. That looks good. And then I subtract here 15 minus 23. I could also do 23 minus my 15. I'm kind of looking for this difference right here between 15 and 23. And that looks like it's going to be 8. And so I'll say negative 8 is going to be my vertical, and 15 is going to be my horizontal. Okay, so these values of 15 and negative 8 are going to actually make up the legs of my right triangle. I'm still going to do a squared and b squared. I'm squaring that negative 8, and that's going to work out just fine because when I square that negative 8, it's going to become positive. This is a really big number, 225 plus 64 is equal to my c squared. So this is going to give you 289 is equal to c squared. And our last step is to take the square root. Okay, So in order to get these lengths, it looks like what we need to do is we need to subtract our x values and subtract our y values. And we can do that even without drawing a picture. Right here on the square root of 289, I tried to do a little simplifying of that. And if it feels like you can't get your square root to simplify by prime factorization or trying to divide out any one of your perfect squares that you already know, go ahead and just leave it like that, and that might be as far as it goes. Okay? So when we talk about the distance formula, basically this is what we have. Here's a little box for notes. If we have a point that is labeled x, and this is called x sub 1 and y sub 1, and another point that is x sub 2 and y sub 2, okay, and the distance from a to b squared, that's our c squared, we can find it by taking x sub 2 minus x sub 1, subtracting our x values, y sub 2 minus y sub 1, it really doesn't matter which one is x and which one is the sub 2 and which one is the sub 1. It's going to work out either way. And then remember this last step of taking the square root? That's what we have right here. So my length AB, this is actually the distance formula. Any distance on the coordinate plane can be determined by taking the square root of x sub 2 minus x sub 1, the difference in the x's, and the difference in your y's. All right, guys. Good luck with the distance formula.